Well, welcome to RDWorks Learning Lab again. Now, somebody brought these to my attention just recently. They're small, they're incredibly cheap, and they're a red laser diode. And I bought a couple to experiment with. There seemed to be a lot of wash around the actual laser point itself. In other words, it wasn't just a red dot, there was a red dot with a red-ish background. Now, I thought that was going to be a disadvantage. But in reality, I think it's actually going to be an advantage because you get a sort of a halo of the mirror around the edge of the red dot. So not only do you get information about where the laser beam is, you get where it is in relation to the mirror itself. I think that will be obvious when we get on to testing it. I haven't yet modified my Mk5 laser pointer to suit the diameter of my new 60-watt laser tube. So this is an opportunity to think about the whole problem again. And because this is a very, very small compact device, it offers its own challenges. Well, eventually I came up with a design, and to be honest, I tried to make it as simple as possible. So we didn't require anything special like springs that people might find difficult to get hold of. I've used these little wheels before on the Mk4, and it's quite staggering to watch them being produced. So I'll program this up and we'll meet up at the machine. Now this is 1.8 millimeters thick. I think it's probably nominally supposed to be 2 millimeters thick. I've got no idea really, but when I've measured it, it's 1.8 millimeters thick. And I've had to adjust my sizes of slots to get the fit that I want. So I've done a couple of trials already. And now I've taken the film off because the pieces, some of these pieces are very fiddly, and if I don't take the film off first, it's very difficult to get the film off. Now I'm just going to stop it there a second, and I'm just going to move this piece just here. Very carefully, because I know that just down here the edge of that might get caught. Now, you're going to be amazed by this next bit. The speed that it does that is quite phenomenal. And the detail on these little pieces is again quite incredible. And there we go, it's as simple as that. Just to put some of these pieces into perspective, I'm just going to put my finger beside these pieces here and you can see just how small they are. Now in addition to these few plastic pieces, we shall need 4, they're M3 posi panhead screws, and they are 20 millimeters long, and we shall also need 4 M3 nuts. And then in addition to that, we shall need some little O-rings. Now these are BS006. They're about 3 millimeter bore, and they're going to fit over those screws eventually. And we shall need 8 of those. And we shall also need a couple of elastic bands. The only other thing that we shall need to help us assemble these, I hope, is a pair of pliers. Okay, the first part of this assembly will be to take one of these big plates, it's the big plate with the largest cross in it. The other one has got a much smaller cross shape in it. And we're going to take this part here, which has got a groove in the top, and we're going to pop that into there. Now it won't drop in, so what we're going to have to do is make sure we push the little foot, the end of the foot, up against the end of the groove, and then with the pliers gently press it into the groove. And then we'll turn it round and we'll make sure again that the end of the slot, we push the foot right against the end of the slot, and then we'll slip it into the groove, and you can hear it snap in. And now we'll do the same for this one. Now the slot in this one is on the underneath, and it matches up with the top slot on this one. If you put them in the other way around, you won't be able to assemble it. So again, we'll make sure that that foot sits right on the end of the slot before we push it in, and we'll push it in partly, and then we'll make sure everything lines up, slots, and we push the foot to the end of the slot and put pressure on it and pop it into the slot. We'll just go around and make sure that they're all pushed down like that. And that's the first part of the assembly, and that's a really nice solid part. Now, although it's a push fit, once the whole assembly is together, it will be self-retaining and self-locking. There will be no screws that are holding the assembly together. It's the adjusting screws that are going to hold the whole assembly together. So I'm making the adjusting screws do several functions. And now we should find that the clearance in these slots allows you to just gently push that on, and that part is now assembled and ready for us when we've built the other part of the assembly. Well, now we're going to use these little serrated nut holders basically. We're going to put the nut into the middle there, line it up with the flats. I'm going to use our pliers to just apply pressure on the top to press the nut in. And there we go. It's biting on the corners of the nut because I've left a little teeny weeny fillet radius in the corner. Okay, now we're going to come to the difficult part of the assembly. What we're going to have to do is to put the little pointy bits upwards. We're going to hold them in pliers like that. We're going to put the chickens facing into the middle. We're going to put the head of the chicken facing into the hole in the middle. I'm going to push it into the slot. We're going to do that for 3 of them, and I've purposely made these slots a tight fit. Here is our little lacer pointer module, and round the centre of here we've got a groove, and the idea is that the chicken's head sits in that groove to hold it clamped against this flat face. So now we're going to slide that into place like that. And then we're going to hold it in place with the 4th one. Now we go around and we push them all in. And now, as you'll see, it's very nicely clamped in there. And that's all held in with the friction of those joints. Now I'm just going to remove my little P-clip off there. And as you can see, I've already extended the cables with a solder joint underneath here, and we're going to now take the other assembly that we built and we're going to put the wires through one of these quadrants, either towards this hole or towards this hole. It doesn't matter which. And what we should really do is to twist this so that it's the little circuit board is halfway between two of these little pieces on here. Now that assembly should go together like that, and what you will notice is that these little pieces here they're part of a circle, and the idea is that they sit on these pieces at the back here and form a pivot point, so that this plate has got a certain amount of universal joint action. There's a limit to what it has got, but it's certainly got enough to give us beam steerage. It's not a proper universal joint, but it's based on the principle of. And now what we're going to do is we're going to put these screws through from the back and put 2 O-rings on there, and then we're going to put one of these wheelie nuts on top. We do it for the opposite one. 2 O-rings and a wheelie nut, and there's our little assembly. So basically what we've got is a pivot underneath here which tries to keep the front approximately the point where the lacer is in a fixed position, and all it does is to steer the beam alignment. We don't want, I could have mounted it at the back, but in which case the beam would have been moving around as well. He would have had lateral movement as well as axial movement, and I don't want that to happen. So what we're trying to do is to just get radial movement without any lateral movement. Although we're going to poke this into the end of the lacer, these wires will disappear below the surface of these screw heads. These screw heads here will sit on the cooling jacket of the lacer, and there will be enough space behind here for these cables to come out. Now the other vital but low-tech part of this are these rubber bands, and what we're going to do with these is just thread them through the slots there and just put a loop on it like that. We'll do the same for the other one, and there we go, just 2 very simple rubber band fixings. So let's go and have a look at see how this fixes onto the machine. The only problem that I've got now is I don't have a 3-volt power supply. So we're going to have to be, temporarily anyway, a little bit inventive. Right, well, we're just going to borrow this keyboard and make a couple of temporary connections into the battery pack here, which should give us 3 volts. And sure enough, we have a beam. So let's go and test it on the machine. Well, the good news is it's now sort of dark outside, so we've got illumination inside the machine, and it will be much easier without the wash of daylight to see our laser pointer. But before we start to use and set the pointer up, the first thing that we've got to do is drag the machine right to the furthest point away from the laser. And then with the power set to a very low value, I've got mine set to about 10%, we're just going to pulse the laser to see where the burn is here. as you can see, it's quite a long way off centre. It's perfectly correct this way, but it's quite a long way off centre. So one of the mirrors needs resetting, but that's not the problem at the moment. What we're going to have to do is, with the beam set as it is, we're now going to have to turn the machine off. So we turn the laser off, not the machine. Because I'm getting old and forgetful, what I'm going to do is take a strip of masking tape and I'm going to put it across the laser switch. That will remind me to make sure that I have got my laser pointer removed before I put the laser back on. So with all the necessary safety precautions in place, let's install our little laser pointer. Now what we've got to do is to put these rubber bands to the back. We slip this into the laser nozzle and we bring the rubber bands through the front, or we bring the rubber band behind the cooling pipes. And we put them over, stretch them over the hooky bit at the front here. And there we go. So that's quite nicely secured onto the front of the laser tube there now. Now what I've got to do is to gently, with these, just steer them. We've got the O-rings on there, so there's a small amount of compression that you can have on each of these. So we have to wind one on and the other one off. Okay, well I've now got the beam approximately aligned up. So now I've got to take the beam up or down. And I have to find out which way I have to do it by winding these wheels a little bit gently. It's actually quite a sensitive movement. Very slightly left or right. The wrong way. Now as you can see, although the beam is correct vertically, horizontally it seems to be a long way out. But if we look carefully at this picture, there's some really valuable information in here because of the scattered light in the background. What we can see is an oval shape, which is the shape of the beam coming out of mirror 2, which is the previous mirror. So we have a problem with the beam going into mirror number 2 because it's already out of position when it comes out of mirror 2. So we can imply from this picture that actually we've either got a problem with mirror 1, or more likely the actual laser tube itself needs slightly realigning. So this is a tremendously useful picture. So what I've now got to do is to adjust the beam, the actual laser tube itself, parallel to get this to come across. Space is back in there, and that's brought it back onto centre. Job done. So it would have taken me ages to do that, to find out where the problem was and how to fix it. So now we've got our laser beam on the correct centre line and in the correct position. Okay, so I've taken the laser pointer out of the machine now, so I can safely remove my piece of tape and turn the laser back on. And now we should be able to do a pulse test, and it should come smack in centre. Not quite. Better, but not quite. Put just a shade more packing behind the laser tube. And there we go. down the centre here, look. We're good. So there's the ideal application for this pointer.